All right, what's up? What's up? It is Wednesday, the 20th. So, yeah, we're gonna get right in. So, just remember, your 3-week progress report is going home today. If you have a D or an F, I have already sent home a message directly to your parents with your progress report saying, "Hey, yo, I'm concerned. I'm concerned about your students' performance because I'm thinking about like what's gonna happen." What's gonna happen when you're in high school? That's what I'm thinking. I'm thinking about high school. What's gonna happen? So please, get yourself together. I know I kind of talked about this on the last video, but I'm just saying, get yourself together and get moving in the right direction. Some students came into my sting session today, and we started getting them moving in the right direction. They still got an F, but they got some assignments turned in, and the work that they did, they're getting credit for. So I'm like, yo, if you did the work, why not get the credit? Come on. All right, y'all. Anyway. Progress reports back by Friday, extra credit. Okay, so I'm handing those out today. Okay, today. All right, we talked about this already, and we really talked about this on the last class, so the last video. So if you have any questions about this, look at the last video. But in class, we're going to spend some time going over it, but not on the online. Go look at the last video. I talked all about this. Okay, moving forward. All right. Then we talked about this right here, and we went over this pretty in depth. And here, let me just skip ahead to one more. I just want to make sure to make a small point of clarification here, okay? So just remember that this M stands for mass, and it's in the unit, and everyone say unit, the unit of kilograms. This is velocity, which is equal to speed, which is equal to distance divided by time. Velocity and speed do not have a specific unit like mass does. Like mass has kilograms. But velocity or speed could be meters per second. It could be miles per hour. So it could be these different things, okay? Now, okay? Now over here with potential energy, it is also this where mass is in kilograms. The height is in meters. And then the gravity is 9.8 meters per second squared. I want to clarify this part right here. And I can't zoom in like I want to, but I want to clarify this part right here is to say, okay, so that part right over there, I'm pointing right to it, right there, okay, is this meters per second is a unit. So when you're entering the numbers in the calculator, you're just going to enter 9.8, okay? That's all you're going to enter. I just want to make sure that that's clear. Now, in class, I gave time to work on this. You really, and I'm not going to read all of this right now. Y'all need to read this. I'm telling you, all of the answers and things that you're looking for are right here. And I'm telling you this, if every time, and I'm going to keep it real, if every time it's time to read, you be like, I'm not going to read. It's like going to the gym, and then every time it's time to lift, you're like, nah, I'll let someone else do it. Or nah, I'm not going to do it today. Or I'm going to do a little bit. That's why you're not strong, right? Same thing. That's why you're not a strong reader. Right? And think like this. You may struggle, but you would be better if you had more reps. Right? It's just like someone who's like, I'm not good dribbling in the basketball. Yeah, you probably not. But you would be better if you dribbled the basketball every day. Right? So I'm saying you need more practice. That will help you to get better, right? You may not be the same reader as someone else, and that's okay. But you just need to be the best version of you that you can be. And that's what I'm talking about. Put in the work. That way you can get the gains, right? And I'm going to tell you, for some of you guys, because someone was mad at me today, like, I'm not good, your class is so hard, this and that. They were saying all these things. And you know what the thing is? It's like, don't be upset for not getting the results for the work you didn't do, right? You're thinking the class is so hard, but the reality is you don't try. You don't try. That's why you're not getting better. And I love y'all, but I need y'all to give me y'all best effort. Give me your best effort. You know what I'm saying? Like, for reals. Don't be upset by the results you didn't get for the work that you didn't do. So if you didn't do any work to try to understand, then of course you don't understand. You would understand some or more. And then my thing is, ask questions. Come and see me during sting session. Watch the tutorial videos where I go through and explain things a little bit more in depth. I'm like, yeah, you can do all of those things. All right, y'all. Let's move on. I'm getting off my soapbox, okay? So, oh, yeah, I'll just move myself up out the screen because I need to do this. I need to do that, right? Oh, where's that at? Oh, it's behind me. So I gotta grab that. Give me the new. Give me the new. Give me the new. Give me the new. Hey, give me the new. There we go. All right, cool. So let's walk through this. I don't know that we're gonna go through all of this in one sitting, but we might. So let's just talk through this whole shebang here, okay? I'm gonna stop and then maybe I can get my video back and then that way I can be on the screen. Okay, I don't know where I'm at, but it is what it is. So we're gonna do what we got. Okay, so here's a couple things. Let's just go ahead and diagnose these first paragraphs, and we're gonna look through them. Okay, real quick. So here's the thing. It says there's one type of potential energy. It's called gravitational potential energy. That is exactly what we've been looking at. So as it talks about gravitational, it depends on an object's height above the ground, which is often measured in meters. Okay, the pull of gravity, so gravity, which is measured in meters per second squared, which we talked about yesterday and we talked about again today, and then the mass of the object, which is measured in kilograms. So that's everything that we need. Then it's telling us what this formula represents. So it's mass times height times gravity. Sometimes it's represented in that way with the dots. I usually use the dots right there, and then mhg, which is just letting you know if there's no space in between them, the assumption is multiplication, right? Then the last thing that's really important right here is that gravitational potential energy is expressed in the energy unit known as joules. So again, right, we're gonna come down here to this page right here. We're gonna scroll on down real quick, and then right here we're going to talk about units and what these things mean. So the meaning of this one is mass. So I'm going to put that in there, mass. And then its unit, and we saw that, hold on, I guess I could scroll up just a little bit. Its unit is in kilograms. So I'm going to put kg. Hopefully you got that. And then this is height, right? And then its unit is in meters. And then this is gravity. And its unit, again, and I just mentioned that, right, is meters per second squared. Okay, cool. So we got all of that taken care of, no big deal. Then if we want to just throw in one more, right, if we want to just say here, and I'm just going to put this up here, is potential energy, and its unit is joules. Okay, that's one I would just throw in, right? By the way, make sure you guys got this written down on your paper, or if you're having to do this at home, you're gonna have to make up your own table and then write it in there. Okay, now an Olympian, and I'm gonna show you how I read through these. So an Olympian lifts 1,375 kilograms, okay, of set of weights, vertical distance of 2 meters. Now you see how as I'm reading all the numbers, I know that's probably what I'm looking for, right? So I'm already highlighting, or, right, you're like, oh, I don't have a highlighter. Don't worry about that. Here we go. At a weightlifting, the force of gravity equals, so gravity is equal to 9.8. You can just do that. What is the potential energy, right? So why am I underlining what is the potential energy? Hopefully you're realizing it's because I'm like, yo, that is the actual, right? That is the actual thing that they're asking for. You cannot solve the problem if you don't know what they're asking for. So this is how I think about word problems. This goes for math. This goes for chemistry. This goes for physics. This goes for whatever. This is how I diagnose word problems. So I always highlight or underline the information. That way I don't have to be digging back through the word problem trying to figure it out. So in this case, right, what is the mass in this case? And the mass, oh, it's 1,375 kilograms. So 1,375 kg. Okay, that's this, right? Boom. So now I'm going for the height. So the height is, 2 meters right there. Okay, and then my gravity, which we know it's the Earth gravitational constant, is 9.8 meters per second squared. Okay, cool. Now the potential energy, that's what we're going to actually calculate. So let me get my handy dandy calculator, and I'm going to use the one that y'all use. So let's see if we can go over here. Oh, I don't want to expose nobody's grades. Let's see. Nope, that's on my, nope. Oh, I think we can't go here. Okay, that'll be cool. Go to courses. Oh, actually, what am I saying? I have it right here. Blah, the bookmarks. I think it's right here. Yep, Desmos calculator. There we are. Bam. So I'm going to go like this. I got my Desmos calculator now. And I'm like, okay, so it's 1,375. So I'm actually, can I make this smaller? Nope, I think it's as small as I can make it. Sorry. So 1,375. I'm not putting any kind of commas or units in there. Just remember, that's how you do that, right? So then I'm just going to say multiply, and then it's 2. times 9.8. And again, I'm not putting any units in there, okay? So then my answer ends up being 26,950. So 950 joules. So then I'm going to go ahead and write this right in here. So I'm going to go like this and say 26,950 joules, okay? It's exactly how it should be done, okay? It's exactly how it should be done. All right, so let's look at this next one and see if we can diagnose right through it. So pause the screen, again, pause the screen, and then see if you guys can work through it, and then come back and let me know. Try and see if you can solve number 3 on your own. All right, let's get into it. Let's get into it. All right, so a child wants to reach the cookies on the top shelf of the kitchen. Doesn't sound like anything, just let me know what's going on. The shelf is 1.5 meters high. Sounds like my height. The cookie of the jar has a mass, it tells me off top, this is my mass, of 0.75 kilograms. What is the potential energy? Okay. Of the cookie jar before it is taken off the shelf. Round the answer. Oh my gosh, round. I need to round to the nearest hundredth. So just in case you're trying to remember, see, like this right here is the 10th place, this first one. This second one here is the 100th place, okay? That is the 100th. So that's where we got to round to, hundreds, okay? All right, now on to what we need to do. So potential energy, I know, right, is equal to mass times height times gravity. So my mass is 0.75. So that's my mass times the height is 1.5 meters. Okay, so that's my height right there. But then what the heck is the gravity? They didn't tell me what the gravity is. But remember, we're on Earth, so the gravitational constant will always work. Okay, so that's 9.8. Oh, I don't got my point in it. 9.8 meters per second squared. Okay, so that is how I'm calculating potential energy. I'm going to put PE down here. And then now it's time for us to just do the math. Okay, do the math. So let me pull up this calculator. Can I not pull up the calculator? What's going on? Oh, I need my Desmos calculator. Where's it at? There it goes. So then I got 0.75. Whoops. So 0.75 times 1.5 times 1.5 times 9.8. That's my gravity. And the answer is 11.025. Okay. So let's go back to this. Okay. Boom. Sorry, we got a little out of whack. Okay, there we go. And then remember, I memorized the answer. It's 11.025. But they said we had to round to the hundredths place, which means we got to round right there, which would end up making this number 11.0. Hey, 5 or more up the score, 3 joules, because remember, it's potential energy, and that's how you would do that one. Okay, cool. Let's go to the very next one. Now this one is going to get a little bit crazy. I'm going to tell you right now. Now off the top, I'm going to go ahead and do a couple of things. So let's just read it and see what's up. So number 4, to raise a 0.48 kilogram box from a shelf, a 6 joules of work is done. How far was the box lifted from the shelf? Round to the nearest tenth. Uh-oh. Now, what are they asking us to calculate here? This is the question, right? It says work is done. How far? So how far was the box lifted? That's what they're asking us. And then we got to round to the nearest tenth. So I'm just underlining information we need. So it looks like we have the mass. And remember, joules is potential energy. So that means we have the potential energy and then, or we have the energy, and then we also have how far. So far is more like a distance or like the height that it was lifted, because lifted means up, so that means height. So we do not have the height, so we're solving for height. So the first thing it tells us is rearrange the formula to solve for height. Now this is where it can start getting crazy. Okay, now here is the formula. Potential energy is equal to mass times gravity, and I'm going to put it in there just because it will help with our understanding, times height. Okay, now some people are like, how in the heck are we going to rearrange? Don't trip, I got you, fam. So let's just talk about this real quick. 6 is equal to 2x. How would we isolate for x? How would we solve for x? The same way we want to solve for h, we got to solve for x. So everyone's like, oh, divide by 2. And whatever you do to one side, you got to do to the other. All right, cool, for sure. So then I'm going to cancel both of the 2's. Now the x is by itself. 6 divided by 2. Hopefully you're like, oh, that's 3, right? So then x equals 3. Now some people are like, I don't like it written like that. That's fine. So we're just going to put x equals 3. Okay? These are the same, though. So it's no big deal. So in the same way that this is how I solve for x, I'm going to solve for h, okay? So this is what I want to get by itself. So since g is multiplied right here, then I can divide by g. Also, just like 2 is multiplied to x, well, g is multiplied to h. Again, we're just applying the same logic and the same math. Now we're just applying it to the variables or the letters, so that way when we go to solve, it's going to be that much easier. And since m is also multiplied, then I can go ahead and divide by that. Now look, cancel, 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 cancel. But whatever I do to one side, I have to do to the other. Times, right, mg. That's what I had. So then, right, and I'm going to make it so that you guys feel comfortable. H, I'm going to take my h on one side of the equal sign, say equals. Here's everything that h is equal to over here, which is potential energy, right, divided by mass times gravity. And just as a reminder, I'm going to put the parentheses to help with the order of operation, because multiplication comes before division, okay? So now that we have our formula here, let's just plug everything in. So H, and then our potential energy is 6 joules. So we're going to put that 6 joules on top, because that's what we see right here, okay? And then divide it by the mass, which is the 0.48, okay? Again, I'm going to put parentheses 0.48, okay, kilograms, times the g, which is the gravity, so that's the 9.8 meters per second squared. And I'm going to go like that, boom, and I got that. So now, if you look, again, potential energy, mass, here's the mass. Gravity, there's the gravity. So now, let's go ahead and get that done up in there, okay? Let's go. Let me move this over to this side. Now watch the way I'm going to put this in. You got to click that return button, okay? So I'm going to put 6, and then I'm going to say divided by, and then in the same way I have this parentheses, I'm going to go ahead and put a parenthesis right there. Boom. Then I'm going to put 0.48 times, and then times my 9.8, 9.8, and I'm going to put a parenthesis. Boom. Just like I have there, just like I have right here. And then my answer is 1.2, right? So the answer is this. Here's the answer. Oops. Ooh, I need it back. 1.27. It had a whole bunch of numbers, right? A whole bunch of numbers. Okay, 1.2755. Oh my gosh. And there's a whole bunch of more numbers, right? So I'm going to need to, I'm going to put the 5 and the 5. And then it says we have to round to the nearest, right? Round to the nearest 10th. That's where it is right there. The 10th is right here, okay? So we need to round there. So 5 or more up the score. So it's going to end up being 1.3 meters, because it's asking us for height, okay? So that is our actual answer there. Okay, so hopefully that helps you out. We walked through a couple of word problems, and we've already done some things. So We'll look at some of these problems in class tomorrow, but what I want you to do is try to solve them on your own to the best of your ability. Then we'll keep going, okay? Number 6 is very similar to number 4. Pay attention to what's going on in number 5 with the apples and the cart and all those things. So that's as far as we're going to get for today. We're already at 20 minutes. All right, y'all, peace!